Hey there! In the last module, we learned how to perform comparison and logical operations for if-else statements and loops. This time around, we'll focus more on sequential data structures and functions in Python. I'll also show you how loops work with sequential data. My name is Jordan, and without further ado, let's get started. Before deep diving into sequential data, it's important for us to be able to first distinguish mutable from immutable data. But you may ask, what do you mean by mutable and immutable data? Mutable means that the object is changeable even after creation. Immutable, on the other hand, means the object cannot be changed once created. I'd like to think of this as tiny houses on wheels versus houses built on lots. Tiny houses can be easily moved to another location, while houses built on lots can only be rebuilt, not moved. Tiny houses in this case would be mutable. Built houses, on the other hand, would be immutable. When coding, you need to consider the immutability of some sequential data structures. In Python, mutable objects include lists, dictionaries, and sets, while immutable objects include numbers, tuples, frozen sets, and strings. Now let's get into this further and dive into mutable data structures. First among the mutable data structures is the list. If you've tried any other programming language, you might notice that the syntax for lists is similar to arrays. Each list is enclosed by square brackets, while each element in the list is separated by commas. Lists are versatile in such a way that they can contain values of combined data types. Meaning, unlike the usual arrays, a list can have a combination of numerical, Boolean, and string values. It can even accept another data structure as a value. For example, we have these lists declared.
What you'll notice in this list is that it contains a number, 2 strings, and even another list as a value. Now, is there a way to access the values, not only of lists, but sequential data structures in general? An index of 0. The same also applies to most programming languages. When we say index, we're referring to the position -1 of the value in the sequence. Let's say we want to get the first value in the favorite things list. What you would need to do is type in an opening square bracket, followed by the index, which in this case would be 0, followed by a closing square bracket. Now, if you go ahead and run the code, it will display shoes, since index 0 would mean the first element in the list, since index is position -1. Therefore, if you want to get the second element in the list, we can do this. We just need to change the index from 0 to 1 to get 8 as an output of the second element variable. You can even change the values if you want to. Let's say we want to change the second element from 8 to eating. You can simply reassign the index to another value, just like how we do it with variables. But how about the fourth element in the list? How do we get the values inside that list? In such cases, what we can do in these so-called nested lists or list in a list is just to add another opening square bracket followed by the index of the nested list followed by another closing square bracket. So, if you wanted to access toxic, which is a second element inside the nested list, we just need to access the nested list itself by entering 3 as the first index and 1 as the second index. As discussed in the last module, for loops are mostly used in sequential data structures. In this case, we can iterate through the favorite things list to access each value easily. What you'll notice though is that it displayed the fourth value as a list. We can also iterate through nested lists, especially if the nested list is too long. For example, we can iterate through the fourth value, circus, toxic, of the favorite things list using favorite things 3 in the for loop declaration. In combination, we can have nested for loops to iterate through values as needed, which in this scenario is necessary to access the values of the fourth value, circus, toxic. We can use the built-in enumerate function to identify what index exactly is the for loop currently iterating through. The syntax will change slightly to be as follows. In this code, we're using two for loops, an if-else statement, as well as the enumerate function to identify the index of each element per iteration. Being able to know the index allows us to execute another for loop if the index is 3. A simpler way to do this is by using increments. For example, instead of using the enumerate function, we're manually tracking the index by incrementing the index value by 1 per iteration. This allows us to track if the current iteration is already at index 3. You can also add values to lists. The simplest way to do this is by using the built-in append function, which adds the value to the end of the list. Simply call the name of your list followed by a period and the append function, enclosing the value you want to add. There are also a lot more built-in methods available for you to use lists flexibly, such as count, pop, and sort. So feel free to explore these built-in methods to your liking. Now let's go ahead and briefly discuss sets. Sets are almost like lists. The only difference is that duplicate values are not allowed and that it's not indexed. In lists, we can have repetitive values such as this one. As you can see, the string values never, gonna, and you were declared twice. In sets, these values can only exist once. Now let's try and convert this list to a set. You can do it by simply enclosing the list by the built-in set function. In this case, set never gonna give you up, never gonna let you down would be the same as set rickroll, since the rickroll variable has this list as its value. Now, if we go ahead and run this code, the second print function displayed values from the rickroll list excluding the repeating values. This is because sets don't allow duplicates. Therefore, the strings never, gonna, and you were only shown once. As you can see, the square bracket also got changed to curly brackets. This is the syntax for sets. To declare sets in Python, simply enclose a single comma separated values with curly brackets instead of square brackets. Now, try to run the code again. Did you notice the arrangement of the values in the set changes every time you run the code? This is because sets don't retain the order of the values, unlike lists. We can access each value by using a for loop, but we can't access it the way we do with lists since sets don't have indexes. Therefore, in summary, a set contains a sequence of unordered, non-repetitive values. You can also add values to sets just like lists, but instead of append, sets have the add function. Simply call the name of your set, followed by a period, and the add function, enclosing the value you want to add. Just like lists, there are also a lot more built-in methods available for sets, such as remove, union, and difference. So again, feel free to explore these built-in methods to your liking. Lastly, we have dictionaries. Although dictionaries are also using curly brackets, just like sets, dictionaries use comma-separated key-value pairs, unlike lists and sets which only have single comma-separated values. Let's take a look at this example of dictionary, which contains 4 tracks with their corresponding singers and song titles. Notice how there's a value on the left side with a colon at the end. That's the key for the pair, while the value on the right side is simply called a value. Hence the term key-value pairs. Keys in dictionaries can be compared to indexes in lists. Just like lists, dictionaries can accept different data types. If we go ahead and replace the keys and values with integers, floats, and Boolean values, the dictionary would still work. You can even go as far as using lists and sets as its value. In this example, we used lists as the value for both pairs. Now the question is, how do we access these keys and values?
The third and last logical operator, not, basically just negates the result of a condition or a logical expression. For example, if we use the not operator on the answer variable, which contains the Boolean value true, the output will be false since this is the opposite or inverse of true.
For dictionaries, we have the built-in functions items, keys, and values to access key-value pairs through a for loop. Now let's go back to our first dictionary example. If we only want to get the keys of favorite songs, we can simply perform a for loop using the keys function. When creating the for loop, simply add a dot after favorite songs, followed by the word keys and an open and closed parentheses. This should only display the artists, not the song titles. Now, if you want to print just values, then we could do something similar using the values function. Again, bear in mind that these loop iterators can be named anything, although it's good practice to be as consistent and descriptive as possible with names. Lastly, to access both keys and the values, we need to use the items function. This time around, we need to have two iterators, one for the keys and one for the values. Just be careful. In case you have lists, sets, or even another dictionary as dictionary values, make sure to have nested for loops just like how we did it a while ago with nested lists to be able to iterate properly. Now, let's quickly move on to these two immutable Python data structures, tuples and frozen sets. I'd like to think of tuples as strict lists. The only difference between tuples and lists is that you can't change the value of the elements, and that we use parentheses to enclose elements instead of square brackets. Since tuples are immutable, we can't do the following. For the fourth element, circus and toxic though, we can still make changes inside that list since lists are mutable. Likewise, for frozen sets, they're just strict sets, meaning the values cannot be modified. To convert a list or set to a frozen set, simply have it enclosed with the built-in frozen set function. Now, you might get hungry with this, but before we wrap up, let's talk about functions. Let's say we have some pizza dough and we want to bake a pizza in an oven. A function would be comparable to an oven in this case. The dough would be the parameter, while the pizza, the end result, would be the return value. Do you need an oven to have a pizza? The answer is no, you don't. You can do other things with an oven, right? The same thing applies to functions. Functions are created to help reuse blocks of code for various purposes without having to type in the code over and over again, resulting in code redundancy. Now let's go ahead and create a function called bake. First, type in the def keyword, followed by the function name, which in this case is bake. Then let's put open and close parentheses. Inside the parentheses, we can put one or more parameters which are optional values passed onto the function. You can name this whatever you like, but again, let's be as descriptive as possible when naming. With parameters, we can use whatever values we pass to perform necessary actions inside the function. For this example, we're just printing the parameter, but we can add so much more to this block of code. Lastly, let's add the return keyword along with whatever value you'd want to use as a return value. Return values are comparable to the values we assign to variables. When we call variables, we get the values we assign to it. For functions, we get that optional return value every time we call it. When there's no return value declared, the function simply executes the lines of code inside the function block. Let's say your oven is on self-cleaning mode. You did not put anything inside to bake, so you're not expecting anything to come out of the oven. It simply does its job, which is to clean itself. Now let's perform a function call by typing in the function name, which is bake. And inside the parentheses, let's type in pizza as its parameter. Now let's go ahead and assign this then to a variable named dinner. The output would be baking pizza, and my dinner is pizza. Just like that, we now have our first ever function in Python.
In this module, we learned to distinguish mutable from immutable data. I also walked you through different Python data structures such as lists, sets, dictionaries, tuples, and frozen sets. We were also able to create our very first Python function. Now, if you remember, strings are also immutable. We can also iterate through strings using loops. We'll talk more about the string manipulation along with the file input-output operations and basic data analysis in our next module. We'll also be using functions more to keep our code neat. Thank you for listening and see you on the next one.